Alrighty, guys. So today you guys went through the PBS learning website where you actually took a block and you measured the mass, and then you also put the block into a liquid. Hopefully you used water when trying to determine the volume. So we were able to determine the volume by water displacement. So knowing that the volume initially began at 25.5, once you drop the block in, however much the water level increases, that is the volume of the object. We use water displacement or any type of liquid displacement to help us try to identify specifically what the volume would be if we had an object that's not a regular shape. Now, I will say the cube that you guys had in the activity, you would just easily have to do length, width times height. But again, if it's something that's an irregular shape, it's a little bit harder for us to be able to say, okay, well, how much is the volume if you can't quite measure the length, the width, and the height. So in your chart, you should have determined what the volume and the mass was for each one. Once you have those two pieces of evidence, you would be able to calculate the density. Reminder that density is a characteristic property. So for example, the density of gold, when we went through, found the volume and the mass, and we calculated was 19.3 grams per milliliter. Remember, units for mass are going to be grams. Units for volume are going to be either milliliters or centimeters cubed. So in this scenario, I went through and I highlighted each of my answers. And as you see, the densities of all these substances range from 0.99 all the way up to 19.3. I may have rounded a little bit differently than you did, and that is okay. Okay, so again, solving for density, you're going to take your mass and divide it by your volume. So I included my equation, one step of work, and then my final answer with units. Both Mrs. Tarloff and Miss Baker are going to be looking for those same 3 steps. And then that way, in case if you do make a mistake, you can still earn credit for completing those problems. You just don't want to write down the answers and not actually show what work you did. We often find sometimes people flip-flop the two. So if you do whoops and you flip-flop, that's just partial credit. So it's not too big of a deal. After you completed that first page, on the second page, it had you start thinking about, well, density determines whether something is going to sink or float. If something is going to float, it is going to be less dense than the liquid that is currently in. If the object is going to sink, that means its density is greater. So for number 3, it says just predict. Okay, looking at our values for our densities in our chart, what do we think would actually sink if the substance had a density of 2.5? So if it's going to sink, that means the density must be greater than 2.5. So you guys should have selected a couple there. And then for number 4, you actually tested that where you could actually change the density of the liquid and then start putting in those different blocks. Again, if the block sank, density, number 5, is greater than 2.5. Okay. All right, scrolling on down to 6, 7, 8, and 9. When we look at the equation for density equals mass divided by volume, mass is on the top of my fraction. So that means if I put a bigger number up top, so if I start out with 1 gram in 1 milliliter, and instead I change it to 50 grams in 1 milliliter, so I only increase the mass. When you do that calculation, you're going to see that my density goes from 1 gram per milliliter to 50 grams per milliliter. So when we have something on the top of a fraction, that's what we call a direct relationship. So if I increase, for example, number 6, if I increase the mass, then I increase the density. If I decrease the mass, then I decrease the density. Whereas for our fraction, on the bottom, volume, this is an indirect relationship. So that means if I instead change my example from going 1, let me fix it really quick. Instead of going from 1 gram divided by 1 milliliter, I'm going to go from 1 gram divided by 10 milliliters. So I increased my volume. So my answer is going to change from a density of 1 to a density of 0.1 grams per milliliter. So do you see how I increased the volume here, which caused a decrease in the density there? Okay, so it's going to be opposite. So for 8 and 9, if the volume increases, density decreases. So they're opposites. If volume decreases, then the density is going to increase. And that should make sense because we already talked about that relationship when we looked at our misconceptions of matter lab. Remember when we had our balloons? And in that balloon, I tied off the balloon. Let's say that I had 5 atoms of oxygen. We're just going to make it super simple. If I added heat, we knew that the volume increased, correct? Because I had a bigger balloon. But now my particles, if you notice, are further spaced out. So when I increase the volume, the density, how tightly packed those particles are, decreases. Whereas if I go the opposite way and I cool it, where we put it on ice, remember that caused a decrease in our volume. So now I had a smaller balloon, still with my 5 molecules. Okay, so now my 5 molecules are a lot closer. So that means I have a higher density. Okay, so if it helps thinking back to that misconceptions lab, when you're asking yourself, okay, how tightly packed are my particles? Rather than just strictly memorizing this or going to our equation and plugging in values to try to come up with, is it a direct or indirect relationship? You can always consider our example of the balloon and say, okay, well, if I have the same number of particles, but in a smaller space, so the volume's smaller, the density is going to go up. Okay, so you can always look at it that way. Now at the end, you guys have a couple test your density skills. So a reminder down there at the very, very bottom, I had said this earlier, but density is a characteristic property. That means it helps us identify unknown substances. Okay, color, mass, volume are not characteristic properties. Okay, right now I have a water bottle that's completely filled. But by the end of the day, I'm only going to have half of it left. Well, I just decreased the mass by half, and I just decreased the volume by half. But it's still water. So when I look at a characteristic property, I want to choose a property that is valid or that is true no matter how much of the substance I have. So whether I have 5 grams or whether I have 50 grams, I know that water is always going to freeze at 0 degrees Celsius, and I know it's always going to boil at 100. Okay, so that's what we call a characteristic property. So again, you're just going through your regular calculation. Density is mass divided by volume. When you do that, you're going to get a value of 19.3 grams per milliliter. And if we knew the density of gold to be 19.3, then yes, for sure, it is gold. So again, for number 11, again, we talked about characteristic properties, where it is a property that helps identify an unknown substance. This is going to be true for no matter what the substance is, however much we have. Okay, so for example, if I'm talking about water, if I'm talking about H2O, if I have a cup that's completely filled versus now a cup that's half filled, again, it's still going to be water no matter what. So we don't want to include mass. We don't want to include volume. I know that I can take water and I can add food coloring and make it red, right? It's still water though. Think about all the different types of metals that we have. Most of them are pretty shiny. So just because they're shiny may not be a good characteristic property. The shape of it, think of aluminum foil. Aluminum foil, you roll it out from the roll and it's a nice little sheet. But then I'm going to wrap it around a dish or I'm going to crumple it up into a ball. No matter what, it's still aluminum, right? So because it has a different shape, doesn't change its identity. Okay, texture, how it feels, also same exact deal. It's not necessarily help us identify the substance. Density, though, boiling point, melting point, solubility, and conductivity all are characteristic properties. So I highlighted those ones for you. All right, moving on to the next one. For number 12, you're just solving for density again. So take mass divided by volume. Boom, and you're going to get 8.85 grams per milliliter, which is pretty close to our copper density, which is 8.86. So we know that for pretty good certainty, the substance that I have, those gold-colored metal beads, are going to be made out of copper. Okay. All right, our last two problems are a little bit harder. They are going to use a little bit of your algebraic skills. So we are going to be manipulating our equation for density equals mass divided by volume. So on the first one, you can see I just set this up as 8.86 equals my mass divided by 10, because it was given in the problem that there are 10 milliliters of copper wire. To get rid of the 10, I'm going to multiply both sides by 10, and then that's going to leave me with my mass alone being 88.6 grams. So that one's just a little bit of algebra. Same with our last one. However, in our last one, we're solving for volume. Since we're solving for volume, it's going to take another extra step for us. So I got volume out of the denominator. So I multiplied each side by volume. So multiplied each side by V. Then I wanted to get rid of the 7.78, which is multiplied by the volume. So in order to do that, I have to do the opposite. And I divided by 7.87 in order to get a volume of 0.032 milliliters. Okay, so whether I am looking for density, mass, or volume, I'm going to use the exact same equation, and then I'm just going to solve for whichever variable is desired in that problem. All right, that's it for today. Nice work, guys.